Okay, so for part E, they give us kindly the Maclaurin series for tan of x. It's this. And they say, use the Maclaurin series for tan of x to find the limit of 4n tan pi over n. And remember, this was the area and the perimeter. This is the area and the perimeter. It's 4n tan pi over n. So let us use this Maclaurin series to do what they want. So it's the limit, as n approaches infinity of 4n times, now we're going to put this into turn this into the Maclaurin series. So it is pi over n. So x is basically pi over n. So pi over n cubed over 3 plus 2 pi over n to the power of 5 over 15 plus ... close bracket again. This equals the limit as n approaches infinity of. So now I'm just going to, well, let's simplify this a little bit first. So pi over n plus, this is going to be pi cubed over, okay, it's pi cubed over n cubed over 3, which is 3n cubed, plus this is going to be pi to the 5 over n to the 5, pi to the 5 over n to the 5. There's still a 2 there, so it's going to be 2 pi to the 5 over n to the 5, and there's a 15, so 15 n to the 5, and I'm going to do ... And the reason we don't need any more terms is because we'll see here, as I divide by this n here, so this is the limit as n approaches infinity. As I divide by n, I get 4 into pi plus pi cubed over 3n squared, because I'm dividing by n, dividing by one of these n's, divided by one of these n's. This will be 2 pi to the 5 over 15n to the 4 plus ... And then all of this equals 4 pi. At this point, you can get rid of the limit, because essentially this n is becoming infinity. So if I put infinity in here and here and here, all these terms just basically turn to 0, and we're left with 4 pi. And that's it. So what happens is this thing. So as n gets bigger and bigger and bigger and bigger, so you can imagine this regular polygon. So as we make it more and more and more and more sides, what happens is it just turns into a circle, because these sides just become so small. Let's see if I can do this. That's not bad. So the size just becomes so small, it turns into a circle. So when he says interpret your answer to part E geometrically, we can say the polygon becomes a circle. Polygon becomes a circle with area 2. Sorry, area 2. What am I saying? Area 4 pi, because this is the area. So area 4 pi and circumference 4 pi. Now really you should get full marks for this, but in the mark scheme, this is why I said 2 there, in the mark scheme it actually mentions the radius, so let's mention that as well. Circumference 4 pi and radius 2, because obviously circumference is equal to 2 pi r, so 2 pi times 2 gives me my 4 pi, and it's also equal to, may as well add this in, pi r squared, and if r is 2, you're going to get 4 pi. So that would be equal to 4 pi, and that would be equal to 4 pi. But it makes sense if you think about it intuitively. As these, as n gets bigger and bigger and bigger and bigger, you just end up with this kind of infinite number of sides, which is ultimately a circle. Okay, that's part E.